Okay, in this video what we're going to be doing is talking about series circuits. So series circuits are probably the easier of the two, series versus parallel. So here's a series circuit drawn on the screen. Series circuit, you can tell that it's a series circuit because it only has one path. The wire doesn't branch anywhere, it's just one pathway, right? Like what is a series of events? That's one thing happens, and then another thing happens, then another thing happens. Well, in the circuit, we hit one resistor, it doesn't split anywhere, it goes and hits another resistor. It's like a series of resistors, right? Another thing we're going to want to remember is that this is a symbol for a battery. So a battery, the positive side is the long side, the negative side is the short side by convention. So what does that mean? That means if this is a 12-volt battery, that means there's 12 volts at the top on the positive terminal and 0 volts on the bottom terminal. There's a 12-volt difference right here, right? The potential difference between these two terminals is 12 volts. All right, so those are some key things we'll want to remember. Okay, so what this question is going to be asking for is to solve for the current. So current, the symbol for current is I. We're going to want to go ahead and remember our Ohm's law and the Watt's law, or the power equation, right? We have E and pi. Those are the two things that we're going to want to remember. E and pi. So what is E? Voltage. I, current. R, resistance, right? I can only solve one equation. I can only solve for one unknown with these equations. If I have the voltage and I have the resistance, I can solve for the current, right? I can't solve, if I only have the voltage, I can't solve for both the resistance and the current. I need to have two knowns and one unknown. And the same for the power equation, right? So P stands for power. That's in the unit of watts. I is current, the unit of amps. And E is voltage, and the unit is volts. E is coming from electromotive force, right? So E, electromotive force. That's where the E symbol comes from. I, they used to call it intensity, so I think that's where that's coming from. And then R is just resistance, and P is power. So you should be able to identify each of these symbols quickly, especially by the end of this project. All right, so we're going to need to know those, and we also have the power triangles on that sheet that we have. It's basically the same thing. So you can solve by algebra, or if you just prefer, you can just use these triangles, right? So we'll probably use the triangle through here. Whichever one you prefer is the one you can do. Okay, so what we're going to look for is current, right? So we want the current of this circuit. So what do we need to do to find the current of the circuit? Well, for all the circuits, what we're going to want to do is combine the resistors. So we're going to make all these and combine the total resistance of this circuit. So if I go to the sheet, on the reference sheet that you have, the Choose Arrow reference sheet 101, you will see on page 7 there's a group of equations, and that equation sheet, if I go to resistors, and it's going to say series and parallel, right? So for series, the total resistance, that's resistance total, that's what that RT stands for, is just going to be add the resistors, resistor 1 plus resistor 2 plus resistor 3, etc. However many there are. You can do unlimited amount of resistors with that equation. So that makes it simple. Series is pretty simple. All I have to do is go 2 plus 3 plus 1, right? So essentially what I'm doing is 2 plus 3 plus 1 is 6 ohms. So I'm just making this equivalent circuit. I did not physically combine all the resistors, but this is just the mathematical representation of that circuit now. So we're going to go ahead and I'm just going to use the the Ohm's law triangle. So I just think it's easy. Algebra is just as easy. But here's what we're going to want to do. So we know we need the current, right? We want the current in the circuit. So we have I is our unknown. We know that E is our voltage, and we know that, and we now know the total resistance, or just resistance is fine, 6 ohms, right? So I use my triangle. The triangle's E equals I times R. All right, so I put in all of my knowns, right? I know my voltage, so the voltage goes here, 12. I put in my resistance, it goes here, it's 6. My current is what I want, so I do not know that. So to use this triangle, all I need to simply do is just cover the unknown with my finger, like this. And what I'm going to do is basically divide 12 by 6, right? So 12 divided by 6 is 2, so therefore the current in the circuit is 2 amps. So to use this triangle, basically, whatever you're missing, you just cover with your finger, right? And you will just divide the two. If whatever you're missing is at the top, so basically, if I'm missing the resistance and I have the voltage and the current, I just cover up the resistance with my finger, and I'll divide the voltage by the current. If I'm looking for my voltage and I have my current and my resistance, that's the only exception. So I'd cover up my voltage, and I would multiply I times R, or my current times my resistance. So we basically just solve for the current. So what's the current in this circuit? It's 2 amps. So that's all we needed to do on this, but we're going to talk a little bit about some other stuff real quick. All right, so with a series circuit, basically what's happening is the voltage is getting shared among these resistors, right? So all these resistors are totaling up. They are coming to total. So 2 plus 3 plus 1 is 6 ohms, right? That was our total resistance. So in a series, the resistors all add up and they push back against the current. Therefore, push back against the voltage. Therefore, the current is a little lower than if these were configured in a parallel circuit. All right. So what's happening is we do know that the top of this battery is 12 volts, right? So all right, so we have 12 volts here. All right, sorry about that. 12 volts here. We have 0 volts here. That means from this part of the battery, the top terminal, all the way to the very tip of that resistor, that is 12 volts here, right? And from here all the way to this part of the resistor is 0 volts. So they ask us this in one question, but we want to have a little bit of understanding, right? So we do know now that the current is 2 amps, right? So could we figure out the voltage drop from this point to this point, right? The voltage drop across this resistor, and the answer is yes, right? So we do know the current in that resistor is 2 amps, right? And we also know the resistance of that resistor is 2 ohms. So if I went ahead and sorry about that, there we go. So if I went ahead and used the Ohm's law triangle again, so here we go, I just want to draw it a little larger. So what we know is our current is 2 amps, and we know our resistance is 2 ohms, right? And we want to solve for the voltage drop across that resistor. So we just cover up the E and multiply 2 times 2. So the voltage drop across this resistor is 4 volts. So if it's 12 volts right here on this side, then what would my voltage be on this side? So it's 12 here. We know that 4 volts are used up. I guess we could say it like that. Across this resistor. Therefore, how many volts will be on this side? Right, it would be 8 volts. So this portion of the circuit has a voltage of 8 volts. All right, so could we do the voltage drop across this resistor here? And of course the answer is yes, we could do that. So we would just do the same equation, right? We're just going to use Ohm's law triangle. So on this one, we know the current is 2 amps because the current is the same everywhere in the circuit. I guess I should have emphasized that. So with a series circuit, there's only one path, right? So if you find the current, that therefore means that the current is everywhere in that circuit, the current is the same. It's always 2 amps. So we know there's 2 amps going through this 3 ohm resistor, so that's 2. Well, what's the resistance? It's 3. So what's 2 times 3 is 6. So there's a 6 volt drop across this 3 ohm resistor, right? So there's 8 volts here. Therefore, what would be my voltage on this part of the resistor? So we had 8, we lose 6, therefore there's going to be 2 volts. Well, just from logic, we should know if there's 2 volts here and we know that there's 0 volts on this side, on the ground terminal of the battery, what should be the voltage drop across this 1 ohm resistor? The answer was obviously 2, right? But if we just use Ohm's law triangle one more time, we're trying to find the voltage drop across this resistor. We know that it's 2 amps, 1 ohm resistor, 2 times 1 is 2, and therefore we are back down to 0 volts. So with a series circuit, the voltage is shared among the resistors, and we get a voltage drop across each resistor. So let me ask you just a quick question to see if you could understand this. So if I put my multimeter, put it right here, 8 volts, and I put it right here at 2 volts. What is this is right, like a multimeter is going to be connected over here, like this, and it's going to have a screen. What would the multimeter read in voltage if I put it? Because what a multimeter reads is the difference between your the two leads that you have. So right here, if I put it here, 8 volts and 2 volts, what should my multimeter read? It would read 6 volts, right? Because it's going to read the difference between those two voltages, the potential difference, right? The potential difference is the voltage. And the potential difference between these two places here and here is 6 volts, right? All right, let's just do one more. What if I put my multimeter here and here? What should that multimeter read this time? So I'll give you a second to look at it. So the multimeter should read 10 volts, right? It's 12 here, 2 here. Well, what's the difference, the potential difference between these two? It's going to be 10, right? If I just go straight to my battery, obviously, and if I put the multimeter on the terminal of this battery, the positive terminal and the negative terminal, what should my multimeter read if I'm testing for voltage? It should read 12 volts. Perfect.